Now, we have another problem presented before us now, and this problem says a motorcycle starts from rest with a uniform acceleration of 25 meters per second square. What is the displacement in the fifth second? The question says a motorcycle starts from rest, right? And it has a uniform acceleration of 25 meters per second square. What would be the displacement in the fifth second? Now, let's bring out our data. We have the only data we were presented with was our acceleration, right? So A would be equal to 25 meters per second square. 25 meters per second square. Now, there we are asked to find the displacement in the fifth second. So we're going to be using the formula S equal to UT plus 1 over 2 AT square. UT plus 1 over 2 AT square. Now, the question says we should find the displacement in the fifth second. So what it's trying to tell us now is to find this. Let's assume this was a graph now showing the time now. So this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, right? 5 seconds. So we're asked to calculate the displacement between here and here. That's what we are asked to calculate. So we're supposed to calculate the distance between here and here. That's what we're asked to find. Now, this would give us that we are going to have to subtract now our distance, change in distance. We're going to have to subtract our change in distance now. We're going to have to subtract the displacement or the distance between the fifth second from the distance covered in the fourth second, right? So let's take this up and let's continue solving. So we have that the distance in the fifth second will be given as UT in the fifth second plus 1 over 2 AT square, still in the fifth second. Now, since our U is 0, because the question says that the car starts from rest, our U will be 0. So our distance covered in the fifth second would be just 1 over 2 AT square, still in the fifth second. Now, that's what our distance or displacement covered in the fifth second would be. Now, for the same thing applies for our displacement covered in the fourth second. So it's going to be S in the fourth second equal to, now remember that our initial velocity now is 0, so we don't need to even write the first part of the equation. So it's going to be 1 over 2 AT square in the fourth second. And I can go ahead to write here 1 over 2, since we know our acceleration is 25 meters per second. 1 over 2 times 25 t square, 25 t square. Let me write this t properly. Now, here I can also go ahead to write 1 over 2 times 25 t square, and this would be in the fifth second, and this would be in the fourth second. So we're going to find the difference between the distance in the fifth second and the distance in the fourth second. Like we have up here, it says that this change in the distance would be the distance covered in the fifth second and distance minus the distance covered in the fourth second. So we have that this gives us our distance now change, our distance change would be equal to distance covered in the 5th second minus distance covered in the 4th second. So this would be, now since we have that the distance covered in the 5th second, we have solved that is equal to 1 over 2 times 25 t square in the 5th seconds, right? And the distance covered in the 4th second is 1 over 2 times 25 t square in the 4th second. So you can choose to subtract that now. It's going to give us 1 over 2 times 25 t square in the 5th second minus 1 over 2 times 25 t square in the 4th second. Now I can choose to write this t subscript 5. Now I can choose to write it as 5 because I'm trying to find the distance covered in the 5th second, and also here I can choose to write this t subscript 4 as 4 since I'm trying, the time there will be the 4th second. Now we have 1 over 2 times 25 t square in the 5th second here, right? So let's factorize this now. Also we have 1 over 2 times 25 times t square in the 4th second. So let's factorize that and let's see how this goes. So this gives us 1 over 2 times 25 times t in the 5th second, t square now for the 5th second minus t square for the 4th second, minus t square for the 4th second. And this gives us, now since we are looking for the time in the 5th second and the time in the 4th second, we can simply just write 5 and 4 square within this bracket. So this gives us 1 over 2 times 25 into 5 square minus 4 square, since we are looking for the time in the 5 seconds and the 4th second. So this gives us 1 over 2 times 25 times 5 square gives us 25, 4 square gives us 16. So this gives us 1 over 2 times 25 times 9. 1 over 2 times 25 times 9. So if you compute that, we're going to have in the end that our distance covered will be equal to 112.5 meters. Thank you so much for watching. See you in the next video.